What happened here? 5, 3, 4. There is going. There is life. Okay. Finally. Okay. Good morning. If you like, if you can hear me. Today we will talk about limits. Okay. Just introduction to limit to review knowledge before. This is a graph here, and then we will explain two examples for limits. The limit, the definition of limit, meaning if you approach a certain point from the left side and the right side, you should have the same answer. Okay. And the symbol for limits, it will be LIM, X approaching any number, and we will see if that has the same value on the right and the left. Like example, if I want to approach this x, which is negative 3, if I approach this one from the left side, okay, which we represent it by limit x approaching negative 3, and we put a sign of negative up, okay, meaning I am approaching this one from the negative side. You can see the value of negative 3, it will give you 2. Y will be 2. Okay, that's why the limit of x approaching negative 3 is from the left side is of this function, it's equals to 2. Okay, let's see if we approach this one from the right side. Okay, if we go from here, we will reach the same point, okay, which is also 2. Okay, this 2 equal to this 2. Okay, that's why we say the limit of x when approaching negative 3 of this function equals to 2. Okay, now this is different from the function because here is the function, meaning we substitute by the value of x in the equation. Okay, this function, if you have negative 3, also to give you 2. This is different from. Okay, now let's see if we have another example. Okay, let's say if we approach 0. Okay, this is the 0 here. The 0. If I approach 0 from the left side, if I go from here, and then I will reach 1. Okay, that's why if I approach x from the left side, I will get 1. But if I approach 0 from this direction, from the positive direction, the right, I will approach 3. Okay, now 1 is not equal to 3, and the definition of the limit, it should be there equals. That's why we can say there is no limit. Okay, the limit does not exist at 0, because if you come from this side, you reach 1. If you come from this side, you reach 3, meaning there is no limit, no such limit. Okay, let's get now some examples of difference. Now let's say how much the limit of x approaching negative 1 of this function. Okay, I have a function here, and then this one. Somebody said I will just substitute in the value of x, Okay, and then I can find how much the value of y. Okay, let's see. This is -1. Okay, -1 cube minus 2 times -1 plus 3. Okay. Now we see this is will give you -1. Let's get another color. Okay, this is -1. Will be just like it's on here, maybe -1 plus, because -2 times -1 will be +2 plus 3. It's 5 minus 1 is 4. The answer of this one is equals to 1. Okay, let's see if that's true. Now, this is, I can draw that one. I'm using Excel to draw that one. You can manually do it or use the application. You can see here, if you are approaching -1 from this side, okay, you will reach this point, which is 4. If you are coming from this direction, okay, you will reach 4. That's why we said the limit is equal to 4. Now, let's get another example. What about if the limit approaching 2 of this function? Now, we have a problem, because this one will be 4 plus 2, 6, minus 6, that will give me 0. Okay, and down is 2 minus 2, 0. 0 of divided by 0 is undefined. We don't know. Is it true there is no limit? We don't know. We need to test it. Okay, we have 2 methods to test it. Here now we will talking about using tables. Okay, I will approach this value, which is 2. Okay, I will use approaching here the 2, but I will not go to 2. Okay, because when I will substitute 2 here, he will give me an undefined. Okay, undefined number. But like I said, maybe I am very near to 2. Okay, let's say 1.9. He will give me 4.9. If I go a few further nearer, 1.99, he will give me 4.99. 1.999, you give me 4.99. You can see here, when I'm approaching 2, you can see I'm not going to 2, but I am approaching 2. I am going to find. This is from the left side. What about from this side? Because this side will give me the same. If you give me the same answer, meaning the final answer will be 5. Okay, let's say I am farther than 2 is 2.1. You give me 5.1. I come few nearer 2.01 and 5.01 and so on. When I reach 2.00001, he will give me 5.0001. Okay, I understand. I am going to find. Okay, both of them, they are giving me 5. That's why we can say is the limit of x approaching 2 of this function, which is x squared plus x minus 6 divided by x minus 2 equals to 5. Okay. Let's get another example, which is the triangle of sine x divided by x. Now, if you use you substitute directly, you will have sine 0 is 0 divided by 0 is the same problem is undefined. Okay, but it's really, there is no, we will see. By the way, here we are including degree, we are using r. Okay. Now, when we approach 0, slowly from this side, okay, approaching here going slowly. We see when we are approaching 0, we are going to 1. But if we come from the right side, 1.1 up to 0.0001, we will approach 1. This is very important to limit x to 0 times x over x equal to 1. Okay. Now, finally, let's get some rules for derivatives for the limit. This limit, by the way, is very important because the next lecture will be about derivatives, and we need all these things to see how we can get that. Now, the limit of any constant, which doesn't matter what he will approach, he will give you the same. For example, if I have limit of x approaching 3, okay, of 5, we said 5 is a constant, the answer is 5. That's logical because when you draw, let's say this is the function, okay, this is the function, which is here is y equals to 5, the black one. Now, when you will go to 3, this is the 3, it will give you 5. Okay. If you go to any number here, let's say 7, okay, it will give you 5 also. Okay. And that's why the limit of constant when x approaches any value of x, real number to be, it will be constant term. Okay, the next one is this one. When the limit of of x when x approaching a will give you a. Example of limit, okay, of x approaching 3, x, you just substitute here, he will give you 3 also. This one is the function of straight line with 45 degree. If this is a 3, it will give you 3 also. That's the second rule. The other rule said if the limit the function is multiplied by a constant, you can get the constant outside. Like example, let's say I have limit of x approaching the 3 of 5x. Okay, if you find this one, it will be 15. Okay, but if this is the same of 5, you can get it outside the limit of x approach 3 of x, it will give you 5. And this one is, we know it's already is 3. And the answer also 15. Okay, this is also a rule when you multiply. Also, we have the other rules for limit. If you add the one I just showed to you, in this case example, the limit of this x cubed plus the limit of minus the limit of 2x plus the limit of 3, if you combine it together, okay, it's the same like we just did it, okay. This example here is the limit of x reaching the 3 of 4 plus 3 x. This will be the limit of 4 and the limit of x here, and then you substitute, you get 7. The same if you substitute directly here. The product is also will be multiplication of the two functions, like this one here. If the limit of this one times the limit of this one the same if you substitute directly. And so here 1 would be 5%. But with a condition here m should not be 0. Okay, what will be the this? But I hope I explain to you limit those in a simple way and you learn. Thank you for